Imagine a professional receives a polished recommendation from an AI assistant. The structure is clean, the trade-offs sound balanced, the language is confident, the conclusion looks sensible. Then someone asks a simple question: why this recommendation? Not what does the document say? Not can the conclusion be repeated? Why is this the right choice, given the evidence, the uncertainty, the alternatives, and the consequences? And suddenly the quality of the document and the quality of the judgment are no longer the same thing. That gap is becoming one of the most important questions in knowledge work. AI can make many parts of cognitive work faster. It can draft, search, summarize, compare, organize, challenge, and check. In some settings, it can improve performance substantially. The temptation is to turn every useful capability into a delegation rule. If the tool can do the step, let the tool do the step. But that rule is too simple. A task can produce two things at once. It can produce an external result, such as a memo, an analysis, a plan, a summary, a piece of code, or a recommendation, and it can produce an internal result, such as understanding, memory, pattern recognition, context, calibration, or judgment. AI can improve the first output while changing the second. Sometimes that is exactly what is wanted. There is no virtue in preserving repetitive effort just because a human used to do it. People have always used tools to move memory, calculation, and routine work outside the head. Cognitive offloading is normal. A calculator does not make arithmetic immoral. A notebook does not make memory weak by definition. Search does not make knowledge worthless. The real question is more precise. When AI removes a step, what else disappears with that step? If it removes only execution cost, delegation can be extremely attractive. If it also removes practice, context, independent verification, or the ability to explain a consequential decision, the boundary needs more care. So this is not an argument for a permanent list of things that AI should never do. There is no evidence-supported blacklist that says drafting belongs to humans, summarizing belongs to machines, or decision-making must always stay on one side of the line. The right boundary is conditional. Delegate more when AI mainly removes execution cost and the result is easy to verify. Keep the human more directly engaged when the work is also building a capability that still matters, when important context is difficult to transfer, when mistakes are hard to detect, or when the person using the output must understand and own the consequence. That sounds almost obvious when stated slowly. In practice, it is surprisingly easy to miss because AI output has one powerful property: it can look finished before the thinking is finished. A coherent answer creates psychological closure. A complete draft feels like progress. A well-structured summary feels like understanding. A confident recommendation feels like a decision. But surface completeness can hide a deeper question. Has the human actually done the work that still belongs to the human? One reason this matters is that AI capability is uneven across tasks. A field experiment with consultants found a pattern that has become a useful way to think about AI. On tasks inside the system's demonstrated capability frontier, AI improved performance. On a task outside that frontier, access to AI reduced performance. The important point is not that one category of work was safe and another category was unsafe. The point is that the boundary was jagged. A system could be impressive on one task and misleading on a nearby task that looks similar enough to invite confidence. That is uncomfortable because people naturally generalize from fluency. If a tool writes a strong market summary, it can feel reasonable to trust it with a market recommendation. If it explains a contract clause clearly, it can feel reasonable to trust its interpretation of a subtle legal implication. If it finds several strong sources, it can feel reasonable to trust the conclusion it builds from them. But competence does not necessarily travel with the label. The fact that AI is good at one form of writing does not establish that it is good at the judgment hidden inside another form of writing. The fact that it can summarize a source does not establish that it can identify which omitted detail will matter to a particular decision. The fact that it can generate plausible code does not establish that it can recognize the failure mode that matters in a specific system. So the first correction is simple. Do not ask only whether AI can perform a task category. Ask whether it has demonstrated enough competence on this specific task, under these conditions, for these stakes. That becomes even more important because adding a human does not automatically solve the problem. A large meta-analysis of human AI collaboration found that combining people with AI did not automatically produce a better result than the stronger performer alone. Human plus AI can be better than human alone in many settings, but synergy is not guaranteed simply because both are present. That matters because the phrase human in the loop can sound more reassuring than it deserves. A human can be technically present and functionally absent. If the system generates the analysis, chooses the evidence, frames the trade-offs, writes the recommendation, and the human gives it a quick final review, the human may be in the workflow without providing meaningful independent judgment. Human oversight is not a position in a diagram. It is a function. What does the person actually check? What information can the person independently access? What kinds of errors can the person detect? What happens when the output is fluent but wrong? Does the reviewer have enough time and expertise to challenge it? Is there a separate verification channel, or is the same system effectively checking its own work? Decades of research on imperfect automation show why these questions matter. People can become over-reliant on automated systems. They can miss errors when automation fails to alert them, and they can accept incorrect suggestions because the system is usually useful. Expertise and training do not make this problem disappear. That does not mean automation should be distrusted. It means reliance should be calibrated. A useful way to see the problem is to ask where the thinking goes after AI enters the workflow. A peer-reviewed survey of knowledge workers offers a cautious clue. People reported that generative AI changed the kind of critical thinking effort they performed. Some effort moved away from producing information and toward verifying, integrating, and managing the result. The same research found that greater confidence in AI was associated with lower self-reported critical thinking effort. Because this was self-report research, it does not prove that AI reduces critical thinking. It cannot tell us that a person's underlying ability became weaker. But it highlights an important design question. If AI takes over production, is the human actually doing the new work of verification and integration? That new work can be more valuable than the old work. A professional does not need to type every sentence personally to exercise judgment. A good editor can improve a draft they did not write. A good manager can evaluate options they did not generate. A good researcher can use a search assistant without surrendering source judgment. But the shift only works if the new cognitive role is real. Suppose AI produces a summary of 10 documents. The human's role is now supposedly to verify the summary. That sounds efficient, but verification is not simply reading the summary more carefully. It requires some independent access to the underlying material. If the human never opens the decisive documents, never checks the strongest claims, and never compares the summary against the source, then the old production work has disappeared without a genuine verification function taking its place. The workflow looks supervised. The supervision is mostly ceremonial. This creates a useful principle. When AI removes one form of cognitive effort, explicitly name the form of cognitive effort that must replace it. If AI drafts, the human may need to frame and edit. If AI searches, the human may need to select and verify. If AI summarizes, the human may need to identify which sources deserve direct reading. If AI proposes a decision, the human may need to inspect assumptions, compare alternatives, and own the trade-off. Delegation is safest when the remaining human role is concrete enough to perform and strong enough to catch the failures that matter. There is a big difference between skepticism and verification. Skepticism says, do not trust the machine. Verification says, design a way to know when trust is justified. That difference is central to good delegation. Consider a simple example. A researcher asks AI to find candidate sources for an important recommendation. That can be an excellent use. Discovery is expensive. Search terms can be narrow. Relevant work can use unfamiliar language. AI can widen the field quickly. But if the recommendation is consequential, the person making it should still trace the material claims to strong sources and directly read the small number of sources on which the decision truly rests. The reason is not nostalgia for manual research. It is that source discovery and source verification are different jobs. AI can help with the first, while the human remains responsible for the second. Now consider a different task, drafting. Suppose an experienced manager has already clarified the evidence, the competing objectives, the risks, and the decision. The reasoning exists. The manager has structured notes and can explain the conclusion without looking at a generated document. Asking AI to turn those notes into a first draft may remove a large amount of expression cost without removing much judgment. The draft can be edited. Claims can be checked. Tone can be adjusted. The manager still owns the logic. In that case, delegating more can make sense. Now change one detail. The manager has not resolved the trade-offs. There is a vague sense of the problem, but the reasons have not been separated. The evidence has not been weighed. The difficult question has not yet been answered. AI is asked to write the recommendation anyway. The result may be beautifully coherent, and that coherence can become an anchor. Once a plausible recommendation exists in polished language, the next human task often becomes editing the answer rather than deciding what the answer should be. The person begins reacting to a frame that was generated before the underlying judgment was formed. Same tool, same task label, very different delegation boundary. Drafting can be execution for one person and cognition for another. It can also be execution at one moment and cognition at another moment for the same person. This is why a universal rule such as never delegate writing is not useful. Writing is not one cognitive function. Sometimes writing expresses thought. Sometimes writing creates thought. The delegation decision depends on which function matters now. This leads to a deeper distinction. Assisted performance and retained capability are not the same outcome. A person can perform better with AI while using it and still become less capable without it. Or the opposite can happen. AI assistance can improve current performance and help the person learn. Both patterns appear in the research. In a large customer support field study, less experienced agents benefited especially strongly from AI assistance. The evidence was also consistent with some of the benefit persisting when the assistance was not available. In that setting, the tool appears to have exposed less experienced workers to useful patterns and practices inside a feedback-rich workflow. That is important because it blocks a simplistic story about deskilling. AI does not inevitably replace learning. It can sometimes support it. Now compare that with a field experiment in high school mathematics. Students using an unconstrained AI assistant performed better while the assistant was available. But when the assistance was removed, they performed worse than the control group on an unaided assessment. A more constrained tutoring design largely avoided that learning penalty. The same broad technology can therefore support two very different relationships with cognition. One design can provide answers in a way that substitutes for the process the learner still needs. Another can structure assistance in a way that leaves more of the learning process intact. The lesson is not that students should avoid AI, and it would be too strong to take an education study and declare that professionals are becoming desk-skilled. The safer conclusion is narrower. Current performance with assistance and later capability without assistance are different things, and the design of assistance matters. That distinction is extremely useful beyond school. Imagine a junior analyst who has never built a financial model from first principles. If AI does every intermediate step, the final model may look professional, but the analyst may not learn how assumptions flow through the model or where errors tend to hide. Now imagine a senior analyst who has built hundreds of models, understands the relationships, and uses AI to accelerate repetitive transformations that can be tested mechanically. The developmental cost of delegation is different. The same operation can be productive automation for one person and premature substitution for another. That is why expertise changes the boundary. It does not produce a simple rule that experts should use more AI and novices should use less. Less experienced users can benefit enormously from good assistance. In some studies, they benefit more. But prior expertise changes both the value of the skipped practice and the ability to evaluate the output. For a novice, a task may be the practice through which pattern recognition is built. For an expert, the same task may be routine expression of patterns that are already deeply understood. At the same time, experts often work on harder, less standardized problems where the system's competence is more difficult to establish. So expertise moves the boundary in both directions. The real question is not seniority. It is what capability still needs to be built, maintained, or available without assistance. This is where cognitive offloading deserves a fair defense. There is a tendency in debates about AI to romanticize effort. If a person no longer remembers every fact, drafts every sentence, calculates every number, or searches every source manually, something has supposedly been lost. That view confuses effort with value. People have always built better cognitive systems by deciding what not to keep in working memory. Notes, books, maps, calculators, databases, calendars, and search engines all move parts of cognition into the environment. Offloading can free attention for more important work. The relevant question is whether the offloaded process is itself doing developmental work that still matters. Learning research gives a clean example. Actively retrieving knowledge from memory can strengthen later learning. That does not mean every difficult act is educational. It means some forms of effort are not merely costs. They are part of the mechanism that builds the capability. So the practical goal is not to preserve friction. It is to preserve useful friction. Copying data by hand may be pure waste. Formatting a routine table may teach nothing. Rewriting a standard paragraph may add no intellectual value. Those are good candidates for aggressive automation if the outputs can be checked. But trying to recall a concept before asking for the answer, generating a first hypothesis before seeing suggestions, working through a calculation when independent quantitative judgment matters, or writing a rough argument before requesting a polished version can serve a different purpose. Those acts can reveal what the person actually understands. That suggests a powerful question whenever AI is introduced into learning or developmental work. Is the goal only to get the answer, or is part of the goal to become the kind of person who can produce, evaluate, or reconstruct the answer later? If capability is part of the output, some direct engagement should remain. This does not require purity. It can be as simple as changing the sequence. Human frame, AI assist, human verify, human reconstruct, human own. Human frame means define the problem before the generated answer defines it for you. State the objective, constraints, assumptions, and what a good result must accomplish. AI assist means use the tool where it expands capacity, generate options, organize information, draft, search, compare, or challenge. Human verify means test the material claims and inputs through a channel that is independent enough to catch the errors that matter. Human reconstruct means be able to restate the logic, evidence, uncertainty, and trade-offs without leaning on the generated wording. Human own means the person who carries the consequence actually accepts responsibility for the decision. That sequence is not a scientific protocol. It is a practical synthesis. But it captures the difference between using AI as leverage and using AI as a substitute for comprehension. The word reconstruct matters more than it may first appear. A person can read an AI-generated explanation and feel that it makes sense. Recognition is easy. Reconstruction is harder. Can the logic be explained in fresh words? Can the important assumptions be named? Can the strongest counterargument be stated? Can the uncertainty be described? Can the person say what evidence would change the conclusion? If not, the output may have been consumed without being integrated. For low-stakes tasks, that may not matter at all. Nobody needs to reconstruct the reasoning behind a nicely formatted meeting agenda. If AI turns rough notes into a clear checklist, the developmental output may be close to zero. Delegating almost all of that work can be sensible. But if the same person uses AI to draft a recommendation that will affect hiring, capital allocation, safety, legal exposure, or a major strategic choice, the ability to reconstruct the reasoning becomes much more important. The higher the consequence, the less acceptable it is for the accountable person to know only what the generated document says. Accountability requires more than approval. Official AA risk management guidance from NIST makes a related point at the organizational level. It emphasizes defining human and AI roles, oversight responsibilities, and whether AI is supporting or replacing human decision-making. The valuable part of that idea is the specificity. Do not say a human is involved. Say what the human is responsible for. Does the human select the evidence? Does the human verify the sources? Does the human decide the acceptable error threshold? Does the human interpret local context? Does the human make the final value judgment? Does the human monitor failures after deployment? A role that cannot be described is difficult to perform well. This is also where context becomes important. Some information is easy to put into a prompt, some is not. A decision may depend on a history of conversations, a team's informal norms, a client's unspoken concerns, the credibility of a particular source, the institutional consequences of a choice, or weak signals that only make sense to someone who has lived with the problem for months. There is no universal number for how much context an AI system misses. Context loss should not be turned into a magical argument for human superiority. The useful point is operational. If important context is not represented in the input, the system cannot be expected to reliably use it. That means context should be treated as a delegation variable. Ask, what information actually carries this decision, and where does that information live? If the answer is mostly in clear documents, structured data, and explicit criteria, more delegation may be possible. If the answer depends heavily on tacit local knowledge, interpersonal consequences, unstated constraints, or judgment built through long exposure, more human participation is justified. Again, not because the task has a prestigious label, but because the information required to do it well is not fully transferable. At this point, a practical delegation test begins to emerge. Before handing a cognitive step to AI, 7 questions can clarify the boundary. The first is purpose. What is the output? Is the goal only an external artifact, or is the activity also supposed to build understanding, memory, pattern recognition, or judgment? If the only goal is the artifact, automation has fewer developmental costs. If capability is also an output, preserve an unaided or actively reconstructive step. The second is stakes. What is the cost of a plausible error? Low stakes, reversible work can tolerate more delegation. A weak draft can be rewritten. A bad list of dinner ideas can be ignored. A rough internal summary can be checked later. When an error is expensive, hard to reverse, or consequential for other people, the standard changes. More independent checking and clearer human ownership become necessary. Reversibility deserves attention because it changes how much can be learned by trying. A low-cost draft can be discarded. A search strategy can be changed. A harmless internal workflow can be tested, measured, and improved. In those settings, generous delegation can itself become a form of experimentation. But some decisions do not offer cheap retries. A public statement, a personnel decision, a contractual commitment, or a major allocation of resources can create consequences before anyone has enough feedback to learn from the error. The more difficult the reversal, the more valuable it becomes to preserve direct understanding before action. This does not mean high stakes require manual production of every step. It means the verification and ownership standard should rise with the consequence. A person can use extensive AI assistance and still retain strong human control if the critical assumptions are understood, the evidence is independently checked, and the final trade-off is genuinely owned. The third is verifiability. Can a meaningful error be detected cheaply and reliably? This is one of the strongest variables in the whole framework. A sophisticated task can be a good candidate for automation if the output can be tested. A simple-looking task can be a bad candidate if mistakes are subtle and persuasive. For example, code can sometimes be delegated aggressively when strong tests verify behavior. A factual claim can sometimes be checked against a primary source. A calculation can be independently recomputed. A structured transformation can be validated automatically. But a persuasive strategic narrative with uncertain assumptions may be much harder to verify, even if the language looks simple. Delegation should track the observability of error more than the prestige of the task. The fourth question is context. Does the task depend on information the system may not have? This includes tacit, local, interpersonal, and institutional context. If the missing context can be supplied clearly, supply it. If it cannot, do not pretend the generated output is based on information it never received. The fifth question is accountability. Who must own the consequence? If someone must defend the decision, explain the trade-offs, answer questions from affected people, or accept responsibility when it goes wrong, that person should understand the reasoning rather than merely approve the pros. The sixth question is feedback. Will reliable corrective feedback arrive? Fast feedback is one of the best conditions for productive delegation. It helps calibrate the tool and the user. If an AI-generated classification is checked immediately against ground truth, mistakes become visible. If a generated code change is tested quickly, failures surface. Weak or delayed feedback creates a different environment. A plausible error can survive for weeks or months, and overconfidence becomes harder to detect. This is one reason delegation can be safer in a tightly measured workflow than in an ambiguous advisory one. In a measured workflow, the output meets reality quickly. A test passes or fails. A customer responds. A calculation reconciles. A prediction can eventually be scored. The human and the tool receive corrective information. In an ambiguous advisory workflow, a recommendation may sound good without a clean way to know whether it was good. Outcomes can take months. Success can have many causes. Failure can be explained away. Under those conditions, confidence can grow faster than calibration. So feedback is not just an operational convenience. It is part of the learning system around delegation. It tells the human where the tool is useful, where it fails, and whether the human still knows enough to notice the difference. The seventh question is demonstrated capability. Has the tool shown that it can do this task well enough for these stakes? Not a neighboring task, not something that sounds similar. This task. Fluent language is not a benchmark. Confidence is not calibration. A successful demo is not a permanent guarantee. The frontier changes as tools, workflows, and tasks change, so the delegation boundary should remain revisable. These 7 questions are not a score that produces a universal answer. They are a way to expose what is often hidden by the simple question, can AI do this? The better question is, what disappears if AI does this, and does that disappearance matter? Now apply that logic to some common roles. Drafting is often a strong delegation role when the reasoning already exists. If the human has done the thinking and the output is easy to inspect, AI can remove a large amount of expression cost. But if drafting is how the person discovers the argument, preserve more of the first pass thinking. One useful sequence is to write rough points, unresolved tensions, and the tentative conclusion first. Then ask AI to organize, challenge, or polish. Search is another strong assistance role. AI can widen discovery, generate search terms, surface alternative explanations, and produce candidate sources. But discovery is not verification. For consequential claims, the accountable person should trace the claim to the best available evidence and directly inspect the sources that carry the decision. Summarization is similar. Use AI for orientation and compression. It can help map a long document, compare sections, or identify themes. But when a small number of documents actually determine the conclusion, direct reading still matters. A summary can compress away exactly the ambiguity, exception, qualification, or local detail that changes the decision. Checking is more complicated. AI can be a useful second set of eyes. It can spot inconsistencies, suggest missing cases, or challenge a calculation. But it should not be treated as the sole independent verifier of work whose errors it may share or reproduce. If the original output and the check come from the same kind of system, independence may be weaker than it appears. For higher stakes work, use a different verification channel where possible. Primary sources, tests, calculations, domain review, direct observation, or another method that can fail differently. Challenging is often one of the most attractive roles. Ask AI for counter-arguments. Ask what assumption is carrying too much weight. Ask for failure modes. Ask what evidence would contradict the current view. Ask for alternative explanations. This can expand the option set without transferring final decision ownership. Consider a team that already prefers one strategic option. Instead of asking AI, what should be done? Ask it to build the strongest case against the preferred option, identify assumptions that would have to be true, and describe evidence that would change the conclusion. The tool is not being asked to own the choice. It is being used to widen the field of attention. That distinction matters. Option generation is often easier to verify than final judgment. A weak counterargument can be rejected. A useful one can expose a blind spot. The human remains responsible for deciding which considerations matter and how they should be weighted. There is still a verification requirement for factual claims. But using AI to challenge a human position can be safer than asking it to quietly choose the position, because the purpose is to create friction rather than authority. And sometimes the right role is to stay out or to be tightly constrained. If the actual objective is to assess unaided capability, assistance defeats the purpose. If someone is practicing recall, reasoning, diagnosis, writing, or calculation, because that independent capability must exist later, the tool should not erase the practice being measured or built. Similarly, if the consequences are high and the responsible human cannot reliably detect or explain errors, autonomous delegation should be limited even when the system is usually useful. Notice what is not on this list: a moral distinction between human tasks and machine tasks. The same task can move across the boundary as the context changes. A summary for orientation may be highly delegable. A summary of the one contract clause that determines a major obligation may require direct reading. A first draft of a routine note may be highly delegable. A first draft of a strategy before the trade-offs have been understood may deserve more human framing. A calculation with an independent check may be highly delegable. A subtle estimate with uncertain assumptions and no feedback may require direct human involvement. A learning exercise may require temporary restraint with AI today so that more intelligent delegation is possible tomorrow. This is why the deepest skill is not doing everything manually. It is knowing what can safely be skipped. There is another important counterweight. As AI gets better, some boundaries will move. A task that is difficult to verify today may become easier to test tomorrow. A system that is unreliable on one workflow may become reliable after better data, better interfaces, or better process design. A novice who needs direct practice this year may become an expert who can offload the same operation later. So this framework should not harden into a new set of rituals. The goal is not to protect human effort from technology. The goal is to protect human capability, where that capability still has a job to do. That includes the capability to notice when the tool is outside its frontier. It includes the capability to recognize important context. It includes the capability to verify a claim without asking the same system whether its own claim is correct. It includes the capability to reconstruct the logic behind a recommendation. And it includes the willingness to own a consequence that no model can meaningfully own on a person's behalf. There is a subtle shift here in what expertise may mean in an AI-rich environment. Expertise may become less about personally producing every intermediate step and more about knowing which intermediate steps can be delegated without losing control of the outcome. That is not a reduction in standards. It may be a higher standard. The expert does not prove competence by doing every repetitive operation by hand. The expert proves competence by understanding the system well enough to know what can be automated, what must be checked, what depends on context, what must be learned directly, and where responsibility cannot be transferred. A professional who refuses all delegation may waste enormous capacity. A professional who delegates everything the tool can plausibly do may slowly lose visibility into the work. The useful position sits between those extremes. Use AI aggressively where it removes cost without removing needed capability. Use it carefully where the output is difficult to verify. Use it as a teacher when the design keeps the learner cognitively engaged. Use it as a challenger when more perspectives are useful. Use it as a drafter when the reasoning already exists. Use it as a search assistant when discovery is the bottleneck, while keeping verification attached to consequential claims. And preserve direct human effort where the work itself is how someone learns the judgment, builds the context, detects the failure, or earns the right to own the decision. The most useful question is no longer simply, can AI do this? A better question is, if AI does this step, what human capability, context, verification, or accountability disappears with it? If the answer is nothing important, delegate freely. If the answer is something that still needs to exist, keep that part of the work alive. The goal is not to keep humans busy. The goal is to keep humans capable of knowing when the machine has helped, when it has failed, and why the final decision still deserves to be owned.